Okay, welcome back to my YouTube channel, Deeper Thinkers Tutorial. So we are here back with what? With another concept of differentiation or method of differentiation, which we call what? The quotient rule of what? Differentiation. The what? The quotient rule of differentiation. So in this case, we apply this rule when we have three functions. I get me? Or we have a rational kind of function to be differentiated. To be what? Differentiated. Do you understand? So if we have y, if y is equals to what? U over v. So it's actually used when we have a function divided by another function to differentiate. To what? Differentiate. So remember that last time we talked about what? Product rule, and we see that product rule is used when two functions are multiplying each other. When a function is defined by two functions that are multiplying what? Each other, and we want to differentiate it, right? So in this time around, we are talking about a function defined by two functions. Are you getting me? That are actually dividing each other. They are what? Dividing each other. So take note that u and v are functions of what? X. They must always be what? Functions of x. So where u and v are what? Functions. Are what? Functions of x. That is u of x and what? And what? V of what? X. So y is defined by two functions that are functions of x, such that u is dividing what? V. Are you getting me? And we want to find y prime or dy dx. Thus we differentiate. We what? We differentiate using what rule? Quotient rule. Using what? Quotient rule. So now let's go. So the formula for quotient rule. The last time I used the example to state the formula, but let's just go with the formula now. Quotient what? Rule. Quotient rule. So what is quotient rule? What does quotient rule tell us? For you to find quotient rule, you have dy dx. For you to get it, you have dy dx equals v du dx minus u dv dx all over v square. Now, a common mistake that students make. So I want to show you a pitfall in quotient rule differentiation. Recall that in product rule, in what? Product rule. In product rule, dy dx is equal to what? What is the dy dx? U dv dx plus what? V du dx. But if we state it like this, if we state it dy dx being equal to v du dx plus u dv dx. Hope you know it will not be wrong. It is same. It is what? It is same. It is still the same thing. But if you make that mistake here, you have failed. You have started to fail. Hope you know. So if you say, okay, since you can state this before this or this before this, let me just bring the u here. Are you getting me? And the v here. You have started what? Failing. Do you know why? What is the reason? Beautiful. I love that word. Because what? This guy is commutative. This guy is what? Commutative. Addition or additivity is commutative. When you add two things, you can swap the other. You can what? Swap the other. It won't change anything. But when you come to subtraction, it does not what? It does not work. It does not what? Work. So if I add 3 plus 5, it will give you 8. 5 plus 3 will give you 8. But 5 minus 3 and 3 minus 5 can't give you the same value. So that is why we are not meant to work with this kind of concept. We cannot work with what this kind of concept here for what quotient rule. So let me clean it out because I was just giving you what the pitfall. So now we have this. For us to work on this now, let's take an example. Let's take an example. Example 1. What do I have? If y equal 2x exponential x over, or let me just take a simple function first, sine 2x over exponential x. Let's take a simple function, sine 2x exponential x. Find y prime. Find y prime. So what are we looking for here? Dy dx, even though we wrote y prime. Why? Because I explained to you initially when I was starting up that y prime can also be written, dy dx can also be written as what? Y prime. It can also be written as other forms which I stated. So if you have not watched that my video, go back to it. Now we have solution. So after watching this, you can go back to that. We have solution. For us to work on this, work on this. Take down the formula, right? Take down the formula. But first, step 1, before you take down the formula, step 1, let u equal sine 2x and v equals what? Exponential x. Now, let me also give you another key point, because my rule here, or my method here, is that I'll be giving you secrets to make you not what? Make mistake. The pitfalls, the things that will make you what? Make mistake, and you'll be wondering, why am I not getting the answer? Why is it not working? Now, take note again. If you come here and say, any of them can be u, any of them can be v, because in this case, in the case of product rule I stated earlier, if you take any of them as u and v, it won't affect you. Hope you know. If assuming I have y equals to what? Let's say 2x that I gave before, sine x. In this case, if I take here as u and here as v, it won't affect as if I take v and u. It won't affect. So if I take here as u and here as v, if I solve it, it will give me the same answer as taking here as u and v. Can we try it out? Let's work it out. Now, if I say dy dx, and I'm looking at it from the perspective of u and what? And v. What will it be? Now, you know, the formula is du dx. No, first, let's have u dv dx plus what? V du dx. If we are to implement that, to have u, what is u? 2x multiplied by cos x plus, let's have v. What is v? Sin x multiplied by what? 2. Are we right? So what if we work dy dx inverse, right? We have v here now and u. What will it give you? Now, following u, what is u? Sin x, okay, multiplied by what? 2 plus what? What will it be now? 2x, okay, multiplied by what? Cos x. Please, is there any difference? It looks different, but it's not different, because this is added to this, and it's still commutative with this being added to this. It will still give you the same thing. So if you are confused, you can take out this as, maybe let's say if you take this as 2 and this as 3. 2 times 3 will give you what? 6. So let's write it somewhere. And let's take this as 4 and this as 7. 7 times 4 will give you what? 28. If you add it, what will it give you? 30 what? 4, right? Okay, let's implement that here. Let's implement that what? Here. This is 4, right? So here it will be 4. 2 is what? 7. We took it as what? 7. Right? Then multiplying this now, have this as what? 2 and what? 3. Right? So this time this will now give you 28 plus what? 6. So it will give you the same 34. So 6 plus 28 is 34. 28 plus what? 6 is still what? 34. Are you understanding something? And so what it means is that anyone you pick as anyone, any letter you ascribe to anyone, we still give you the same what? Answer. We still give you the same what? Answer. It won't change it since it is commutative. Since it's what? Commutative. So we don't have problem. But if you apply that concept in quotient rule, you have problem. You have what? Problem, because it is not what? Commutative. So you must take the first one, the one up as what? U, and the one down as what? V. Strictly. What? Strictly. But in product rule, you can what? You can be lenient. You can be what? Lenient or free or carefree or reckless. Anyone can just be loose. Can just be what? Loose. So we have this. We have what? This. So for us to work on this now, step 2 will be what? Step 2, what is step 2? What is step 2? What is step 2? Apply the formula. So what is the formula? What does the formula say? That dy dx equals v du dx minus u dv dx over what? V squared. So this is what we're having, right? So what will y prime give us, which is dy dx? So we agree. What will it give us? What's our v? We know our v. But do we know our du dx? We should have done that also. We should have done that also. Let's do it here. Thus, we have that our du dx will give you what? 2 cos 2x. Please take note. Why is this so? Because I told you that anytime you're differentiating cos, first differentiating all these 3 functions, sine, cos, and tan, differentiate what is in the front first. Are you getting it? So take out 2x and differentiate it. What will you have? 2. Multiply by, find the standard, are you getting me? Derivative. So this is what you will memorize. There's no special way of knowing that sine x is cos x. No. It's what you will memorize. That anytime it's very sine, you get what? Cos. You have to memorize those standard. And I will still give the standard derivatives here for you to memorize. So when you differentiate this, it's always same that you always get what? Cos. Then what is in the front does not change. It does not what? Change. It does not what? Change. So differentiate what is in front, write it down, find a standard derivative of cos, write it down, then put that same thing that has been in front before here. You are done. You are what? Done. So now for us to go on, we have to find what? Dv dx. What will that give you? Dv dx. It will still give you exponential x. But say anytime we differentiate exponential x, so long as there is nothing on the exponential apart from x, it will still give you what? The same. It will give you the same what? Answer. So now we have this, right? This now because of v. What is v now? We say v is exponential what? X. What is du dx? 2 cos 2x, right? Minus, what is u? Sine 2x. What is dv dx? Exponential x. Are we there? Over what? V. What is v now? Exponential x. So you square it. You what? Square it. So this is like the final answer if we want. But for clarity's sake, for what? Clarity's sake, and to show a lecturer that you actually understand what you are doing, is preferable you simplify it. You clean it up. You what? You clean it up. So going for what we have up there, what we have? It will be exponential x, and you open the brackets to be 2 exponential x, right? 2 exponential x cos 2x. Do you agree? Do you agree? We have this multiplied by this. We have that. Minus, right? This multiplied this will give you exponential x what? Sine 2x. Is there any other stuff? Over what? Exponential what? 2x. Because just as in this is, anytime you have 2 powers like this, the product is what you have, right? So beautiful. So we have something of this nature. Can we further do something? No. Did you say no? We can still do something. Because even from here, I would have done it. But I just wanted to see why I'm doing what I'm doing. Here, I can factor out exponential x. So exponential x comes out. We have 2 cos 2x minus, we have sine 2x over, this is the same thing as saying exponential x times exponential x, because if you remember we said exponential x squared, right? So it means exponential x multiply itself. Square means that thing multiplied by your what? Self. Do you understand? 2 square means 2 times what? 2. So we take out that and we what? We cancel. We what? We cancel. We what? We cancel. We what? We cancel. So we have that as our final step to getting the final or more, the least simplest form. Are you getting me? The least simplest form. That's the lowest simple format. Now we can have this as 2 cos 2x minus sine 2x over exponential x, and that is where we what? We wrap it up. What? We wrap it up. So thank you for watching. This is the what? Like the example of what? Quotient rule. See you in my next video, or maybe further problem on quotient rule or implicit differentiation. Subscribe, like, and comment, and see you in my next video.